Engineering. We as engineering students at ASU are going through very similar programs, however not all engineering is made the same. I, Alec Doyle, am going through mechanical systems engineering. Oscar is a robotic systems engineer, and Jasvir is studying to be an automotive systems engineer. What differentiates each one is specific to each person. Oscar feels that robotics includes more software and electrical concepts. He works with not just robots, but artificial intelligence. Robotics is a subset of mechatronics, and all robotics are mechatronics, but not all mechatronics are robotics. He works heavily in CAD software, such as SolidWorks, and he works very heavily in design. Whereas I feel that mechanical systems is the broadest of engineering. It incorporates mechanical, robotics, electrical, and more. It's about the operation from top to bottom. And Jasvir feels that automotive is a very specific subset of mechanical. It's similar, but way more focused on automotives, such as the chassis, the engines, transmissions, etc. For a day in the life of an engineer, engineering differs itself from other professions in that there are a lot of group projects, and you do a lot of work with teams, both in the office and in the field. Engineering is highly niche. You yourself do not work on the entire project. You work on a small piece, and everyone else works on their small pieces, and everything comes together at the end.
As a robotic engineer major, being able to use and interpret data daily is a required skill. To be able to design new products on machine, careful planning and extensive research needs to be done beforehand. For example, engineers would need to extract important data from an experiment in which they test how some metals react to different temperatures. Using the data collected from the experiment, an engineer must then analyze the data to find correlation between the variables. Once this process has been completed, the data can be interpreted to find material that meets the minimum safety requirements and best performs at a high temperature. For example, niobium, a material that is used in the design of an airplane turbine, which must be able to withstand a tremendous amount of heat. Collecting data and applying statistics could also be useful for engineers trying to improve the lifespan of a battery. When researching different materials that can store energy, engineers should collect data about how long different types of battery last. After this research, with the use of statistics, they could find the necessary battery that would perform the most efficient but not burn the new design. Finally, a third example would be how an engineer might be able to diagnose an issue with a car from past data with the use of sound and intuition. For example, when a car shakes while brakes are being lightly applied, an engineer will quickly be able to identify the problem from the shaking alone. Based on past experience and the warped brake pads are most likely to be cause of the issue, causing the car to shake even when light braking is applied. Although an engineer might know this because of past experience, the application of stats to these scenarios can help to save time and money in the discovery of the problem. An experiment testing the effects of warping on brake pads could help engineers easily diagnose the issue, as well as prevent the issue in the future by discovering what material of brake is least likely to warp. This process of being able to diagnose mechanical issues from signs and warnings is a skill that successful engineers must have.
To help resolve one of the 14 National Academy of Engineering Grand Challenges for Engineers, our three majors can help by designing water treatment plans, using automation and robotics in water treatment plants, and transporting clean water. Mechanical engineers are used to help design the piping and flow routes for the treatment plants and also distribution systems, and are responsible to make sure that those systems operate appropriately and efficiently. Mechanical engineers also design the tools, engines, and machines to perform functions such as delivering the required rate of treatment materials into the water supply. The involvement of automation and robotics with the water treatment industry is chiefly driven by the need to perform accurate and low-cost functions while managing and treating water appropriately. The key factors that are urging water utilities to resort to robotics and automation include hazardous conditions of operation, high wastage levels and cost, and high probabilities of human error and accidents. Unlike mechanical and robotic engineers, automotive engineers are involved with providing clean water indirectly. The main focus for automotive engineers would be to have a clean source of energy for transportation of the water to locations that are in need of it. By the use of alternative fuels and clean energy sources, it'll help reduce pollution and oil mining in the ocean, which has affected the cleanliness of water in the past and overall could eliminate that entirely in the future.